Today we have discussed the problem Mercury, Pluto of masses Mercury and Pluto of mass 3.58 and into 10 to the power 23 kilograms, and mass of Pluto is 1.27 into 10 to the power 22 kilograms. And what is the Kepler's law ratio? R cube by T square. So here we know the Mercury and Pluto both are moving around the sun. Okay. So here, when we are considering a motion of a planet around the sun, there will be the force of gravitation and the centripetal force. Force of gravitation is given by G m by r square. Here G, gravitational constant, capital M, mass of the star sun, okay, around which the planet is revolving. M, small m, is mass of the planet. R is the distance between the planet and the sun. Okay. So this force must be identical with the, or this force must be equal to the centripetal force, that is mv square by r. Here v is the velocity, linear velocity, or it is given by 2 pi r by t. Here 2 pi r is the circumference of a circle of radius of, if the planet is moving in a circular path having radius r, then 2 pi r is the circumference, and capital T is the time for one revolution, that is period. So when you use this relation, equation number 3 in equation number 2, then it will be equal to Fc is equal to m into v square, that is 2 pi r by t, the whole square by r. So m into 2 square is 4, pi square is pi square, r square by t square r. One r is getting cancelled in this expression. So the centripetal force is given by 4 pi square m r by t square. This is our equation number 4. And according to the conservations, the gravitational force or according the gravitational force and the conservation centripetal force are same. So here GMM, gravitational force GMM by r square, must be equal to 4 pi square m r by t square. The small letter m is there on the both numerators, you can cancel that. And I am making some rearrangement, that is this r square on the left denominator is taken to the right hand side, then it will be in the numerator, and the 4 pi square on the right numerator is taking to the left of the equal sign, that means it will get into the denominator. So that Gm, the 4 pi square on the right numerator is moving to the left, then it will be in the denominator, that will be equal to r square on the left denominator is coming is moving to the right hand side, then it will be r square into r, that is r cube by t square. So that relation, that is r cube by t square, is equal to gm by 4 pi square, gm by 4 pi square. This is the Kepler's ratio, r cube by t square ratio, and this ratio is depending upon the gravitational constant, mass of the star or planet around, mass of the star or the sun around which all the planets are revolving. T is 4 is a constant number, pi is also a constant. So the r cube by t square is independent of mass of revolving planets. So the planets Mercury in this question, the Mercury and Pluto both are revolving around the sun, and we have to find the ratio r cube by t square of Mercury by r cube by t square of Pluto. And if you are using the relations, gm by 4 pi square is for Mercury, and that same value gm by 4 pi square is also for the Pluto, and you can cancel that. That means it is the ratio 1 by 1. So the answer is 1:1 is the correct answer of that particular question.